Hey, welcome, Ethan.
Thanks for having me.
Let me get the names here. Is that correct? Yes. Okay, so Ethan, you are a maintainer for Fastify and an active open source contributor to Node.js. You're currently employed as a software engineer by Microsoft, based out of Cambridge in Massachusetts. And when you're not working, you can most likely be found hiking, skiing, or camping somewhere in the Northeast US. Have you been able to do that this year?
Yes, in fact, I actually am living in Vermont right now due to the pandemic. I've escaped the city of Boston and have fled to the woods.
Oh, okay, that must be lovely.
Yes,
Okay, so today you're going to be talking about advanced TypeScript definition patterns with Fastify.
exactly. Yeah, my talk today is going to be a fun one. We're going to dive into some Fastify stuff and also doing some code sharing on TypeScript Playground. So if we're ready for it, I can share my screen and kick this off.
Yeah, let's do that.
All right. Let's see here. We're just going to share the whole screen. That'll be easiest. Cool.
Cool. All right.
And you should be able to see this now. All good. Oh, here we go. All right. Hello, everyone. Again, my name is Ethan, and today we're just going to be talking about some Fastify in TypeScript. For those of you who don't know, Fastify is a Node.js web framework, very similar to that of the likes of Express or Happy. In fact, we work alongside many maintainers from other frameworks inside of Node.js to make sure that we're all working towards a common goal of providing developers the best web framework developer experience as possible. And that's really the core to my talk today is developer experience. Fastify itself is written entirely in JavaScript. So because of the attraction of TypeScript over the past couple of years, we recognize that Fastify should do something to help those TypeScript developers. And what that was is we went and we wrote our own type definitions. And a lot of projects do this or have community contributions through Definitely Typed. But Fastify was a bit more unique because of the way our application is built, of the way Fastify API is built, we had to do a lot more heavy lifting, so to speak. And so without further ado, let me jump into the first topic of my talk today, and that is discriminant unions and function overloads. To define what a discriminant is, it's a characteristic that enables things to be distinguished from one another. And inside of TypeScript, these discriminants can be used for type narrowing. So you've commonly seen things like a switch statement, and each case of a switch statement would correspond to some of these distinct characteristics. To give a little bit easier of an example, let's consider this fictitious union I have here called fruits. And it's made up of an apple, an orange, a strawberry, and a watermelon. The common fact for all four of these, and what makes them the ability to be like unioned, is the fact that they're all fruits. They all have that in common. Similarly, they all have a color and they all have seeds. But the apple and the strawberry are special because they are the color red. The apple and the orange and the watermelon are unique because they all have inner seeds. And the strawberry is unique because it is the only one of this union that has outer seeds. And then, of course, the orange and the watermelon are also unique in their own ways because of their color. You know, the orange is, orange, and the watermelon on the outside is green. And so this kind of union, while fairly trivial and fairly obvious, there is a distinct difference between each of these four entities, where if I was to ask you which one of these items is the color red and has outer seeds, you could immediately tell me which one that is. There's no ifs, ands, or buts about it. Similarly, if I asked you, what about which one of these items is the color orange? again, there's only one option. And it's these kinds of characteristics, these unique identifiers, which are considered the discriminants. Now, there's other properties that could exist here. For example, I said that these are fruits. They have color, they have different seed orientations. So what if we threw in something like a banana? Now we've added a new color, which would be yellow. In this current example of these 4 fruits, there is no yellow option here, but the yellow characteristic could still be true in the sense of if we were to consider an expanded union of this sense, we would have to consider the other possibilities. But in the context of Fastify, we use discriminant unions to differentiate between HTTP servers. So let's jump into the playground link, and I actually have it already open for us. And let's make this a little bigger. So we'll start off here, where here is our union of 4 different HTTP servers, the 4 that are provided from Node.js. The basic HTTP, the HTTPS, and then the 2 different HTTP2 servers. For what it's worth, you would rarely use this one in production because it's, by implicitly, if you're using HTTP2, you should use it in a secure mode. But it's important that we have all 4 available because that is what's offered by Node.js. In our type definitions, let's start with this first interface called the Fastify instance. And this will make a little bit more sense in a moment. But here it has a single generic, server extends servers. So this generic parameter server is going to be one of these 4. And in this simplified example, we're just immediately passing that generic to this other property raw. In the real Fastify, there's a ton more properties. In fact, in later examples, I'll show you a couple more things the Fastify instance can do than just share what kind of HTTP server it is. But the important thing here is that the Fastify instance needs to have a specific HTTP server. And so how did we do that when we have only one entry point? Well, we use discriminant unions over the different options for this function. So the Fastify function is the one and only entry point to the Fastify API. You can see here an overload, and each one of these overloads has a generic server, which extends from one of the 4 different HTTP servers. It's also defaulted to that same HTTP server as well. Then on the right, you can see in this same type definition that they all share one parameter, options. And these options, though, are all different. It starts here with HTTP, then we have HTTPS, 2, and then 2 secure. But at the end, all 4 loads return the same thing, a Fastify instance with that server generic. So what makes this unique? Well, if we take a peek at these type definitions here, we can see we're with the HTTP options. This is just a basic type with one optional property, logger. And very similarly, enable or disable a logger for your Fastify application. The next type is the HTTPS options. It's an intersection of the HTTP one from above, but it now has a new required property, HTTPS, which corresponds to the server options from the HTTPS library in Node.js. The next type definition is HTTP2. Consider this one the insecure HTTP2 types, where again, it's an intersection of that first baseline HTTP options object with this new property that's also required, and it's a Boolean literal for the HTTP2 property. This is how in Fastify, we enable our users to create an HTTP2 server. And then finally, we have the secure option, where again, it's that same base object, but the intersection this time has 2 required properties. HTTP2 is again a Boolean literal of true. And now we have that HTTPS property again, but this time pass in the HTTP2 version of the options. So with these 4 types here, and combined with this function overload, TypeScript is smart enough to actually infer which of the 4 overloads we're using based solely on whatever options object you pass to your Fastify instance. What's even more cool is that this baseline definition here, notice how the options are optional. So we can also state that if you don't provide us any options, which is a valid case in Fastify, we will assume you just want an HTTP server, which is exactly that. Because in consideration, if you want to make an HTTPS or an HTTP2 server, it's an opt-in operation. You need to provide us with the certificates and keys to make your server secure. And for HTTP2, we need to know that you want to switch to that protocol. And that's why we ask you to say, hey, like, let us know, are you going to want to use HTTP2 or not? So to see that, in example, we have these 4 constants, F1, 2, 3, and 4. And you can see how in this current one, there's no options object. And the type sense here says, hey, that's a Fastify instance with a generic of http.server. Perfect, exactly what we wanted. Same with F2. We're passing in just the HTTPS option. We're not enabling HTTP2 yet. So Fastify knows, hey, we want an HTTPS server, and so on and so forth for the other 2. And we can even further exemplify this, or if you do const f1b and we say equals Fastify, and we provide that logger type here, you can see that f1b also gets that HTTP server type, because again, we're not providing HTTPS and we're not providing HTTP2. But if we were to go ahead and add that logger prop to another one of these, it would still work fine. And it still thinks it's the current server because it has that discriminant characteristics that we created in our function overload. Awesome. So now let's jump back to the presentation and move on to the next fun part of some of the things that we've done in the TypeScript definitions. This one is called named generic parameters. And most JavaScript developers should be very familiar with just named parameters in general, where if you have some function f, it takes a single argument that is some object. And then that object is structured inside of the actual functional implementation so that the user can provide the parameters for this function using named attributes rather than using some sort of argument order. And if I can go to the TypeScript playground again, we can do a very similar thing in TypeScript as well. So here in a new TypeScript playground, I'm going to jump down to the bottom here and talk a little bit more about what we're going to sort of be walking you through. And this is also going to be brought up later in the talk as well about this whole request object. So I recommend paying attention to this part just a little bit more. Here is an example of a Fastify server where I'm using a little bit of typecasting just to sort of like pretend we're instantiating a real Fastify instance. But the point is, there is these methods to create routes on Fastify, just like Express and like Happy, where the first argument's a string, and then the second argument is this route handler. And this route handler takes this first argument, the request object, and that request object contains the details of the incoming request. Things such as the query string, the body, if it was, a post or a put, the headers for basically any request, and is also parameters if that was passed into the URL. And in Fastify, we automatically figure all of that out for you. And we'll get to that. We'll get to the reason why we do that for you in a little bit. But just know that it's done for you underneath the hood. So in a JavaScript application, destructuring these 4 things from the request object is valid and easy to do. But those that know about runtime issues in TypeScript will immediately be thinking, okay, but like, how can we be sure that this body is of some type because it's coming from a external request? And the answer is we don't. We actually need to validate that. And we'll get to validation in a little bit, but to sort of jump ahead, we want to say, okay, if we can validate what these 4 things are from our request object, we should also be able to provide a type for them. And we could use typecasting like this, but typecasting can get a little messy because usually it's again, the developer has to do it. And honestly, most of the times they have to do something like this, where they're like const, and then it's like, query string 2 equals query string as, and then, some type. And let's just pretend it's a string here. And now the query string 2 property is this query string, but as some other type. But we've come up with a better way to do that. In the second example, you can see it's the same post request as I defined here, except it now has a generic. And in this generic, we have corresponding properties for the various aspects of our request object. And then inside of this route handler, you can see that the string type is assignable to the query string. And same with this record type that we passed here is assignable to this body. And now the way we're able to achieve that is through these named generic parameters that this whole section's about. So starting up here, we have this interface. It's called route generic. All 4 of these properties are optional and they're defaulted to unknown. Then we have this other interface. This interface is the request interface. That is what is corresponding to that request argument in the route handler function. You can see those types here and here. But you can see inside of this interface, we have that generic R. It extends from this route generic interface. And then inside of that interface, we're actually able to use these strings to access this interface, generic interface R. And doing so, it'll default to this unknown value because here on line 17, we're saying, hey, R extends that same route generic, but we're also defaulting it to itself, the route generic. And then that's passed down. The route handler gets that generic parameter R, which it then passes down to the Fastify request. And then at the end, Fastify request gets this generic and can apply it to these 4 corresponding properties. So this is one of the ways that users can also optionally set different parameters here, where, for example, if they still want their headers and parameters to remain as unknown, they can do so just by omitting it. The alternative solution here is having an ordered generic, which is what most people are used to seeing, where the first one could be query string, the second body, third headers, fourth parameters. And if you have a request that only wants to specify the parameters type, you would need to then provide either some sort of default for the first 3 or some sort of like undefined or unknown for the first 3. And that can get a little messy in your code. So it's much better that we let our users sort of opt in to the properties they want to be typed as they go. And now, some might think that this actually is not type safe. And you're right, it's not. It's not inherently type safe right now because there's nothing verifying that this query string and body here are actually what I'm saying they are. Because who knows, what if the user didn't pass in a query string to their request for this route? Now this query string might be null, but our types say it's string. So what do we do about that? Well, I encourage you to hold on to that question because I'll answer it in a little bit when we start talking about some of the advantages that come with TypeScript 4.1. So back to the presentation. I have one more little thing I want to share, and then we'll sort of go back to the ideas of this validation part of our, this dynamic aspect of our data. And this is declaration merging. This is something a lot of people are familiar with, especially those dealing with external modules. Plugin systems are hard in TypeScript, and in Fastify, everything is a plugin. I don't want to get too much into details what that means, but the point is, in this little code snippet you can see here, we're using one of my favorite plugins, Fastify Multipart. It enables the multipart request stuff, so you can send files to a Fastify API. And you can see here that this request object now gets this new file method, which is a promise, and it resolves some data object. And that data object contains a read stream under the file property, and then as well as a write stream. And then as well as has a file name as the as a string that can be used in a method such as a write stream for creating a write stream. In this sort of crude example, we're just sort of pumping the data that's coming in straight out into whatever the server host is. So I also have a TypeScript playground link for this, but I don't think it's as valuable because this one is really demonstrative over what would be considered a project, multiple files. And so let's start with the top left here. And this is fastify.ts. You can see we have two interfaces, request and response. The route handler and route method, which I've already shown previously, have been much more simplified for this example, where there is no more generics, and we just have the request and the response object, and this route handler is promise-based. And then that route, wraps that handler as that second argument. And then here inside of our Fastify instance, we have those our HTTP methods, get, post, put, and they all correspond to a route. And then taking a peek at our app.ts file, you can see that we're creating that server based off of what's exported from Fastify. But then inside of our request handler here, notice how we're calling request.file. But this request interface doesn't actually have that property. We have no properties in it for this example. So then how does our project know that the file method exists as well as the file property, as well as this file name property? And that's the power of declaration merging. Inside of Fastify multipart, which you can see we're importing on line 2 of our app, is declaring this Fastify module. And we're saying inside of that Fastify module, we're going to export this type called data. And data is going to be a file as a read stream and a file name, which is a string. And the interface, Fastify request, now has a new method file that returns a promise that resolves with that data type. And you might be thinking, oh, wait, that's the same name. And that's how declaration merging works, where if you declare a module that also exists in your project, such as fastify.ts here, TypeScript will infer that, okay, let me take all of the types defined inside of this block and merge it with all of the definitions defined in this block. And then inside of my project here, app.ts, I get both types. I get those that are defined from Fastify and those that are defined from the plugin Fastify multipart. And yes, this isn't a perfect solution because who's to say, just because you're importing Fastify multipart, that you're actually using it? And unfortunately, I don't have a great answer for you. Plugin systems in TypeScript are really hard. And because Fastify is written in JavaScript, we're sort of limited to what we can do. If this was a TypeScript project, there might be a better API that we could develop that creates the correct encapsulation for these plugins and such. However, again, this is a JavaScript project and we're providing TypeScript definitions on top of it. So we sort of have to give and get, and we have to meet in the middle or compromise, so to speak. So great. On to the last kind of part of this talk, and that is some of the new template literal type features that are coming with 4.1 and something that I'm really excited about. So here are 2 tweets that I've had tracked for a while. The first one on the left is about URL parameters. In fact, it's talking about Express in this example where using these new template literals, you could give some sort of route and then derive the information of that route just purely using type definitions. And I thought that was really cool and actually really impressive. Now, I don't know how applicable this would be in Fastify since we sort of apply that information through our own API, but it just shows off other cool things that template literal do. On the right, though, I want to start getting everyone thinking about a JSON parser using TypeScript's type system. So this example is way too big to fit in a single slide. But if you're interested, you can go to this link here. It's a shortened TypeScript playground, and it has, it's basically this link that this tweet has, but shortened. And I want you to think about what could the possibilities be if we could build an entire JSON parser using TypeScript definitions alone. Fastify has this concept that I mentioned before about validation and serialization. It utilizes JSON schema and JSON schema validation. Our particular library of choice is AJV, another JSON validator. And we use this validation and serialization feature to make our routes faster and more secure. And what I mean by that is, here in this example, we're providing this schema as the second argument to this route. When a schema is provided to a route in Fastify, the Fastify engine will take that schema and do two things with it. First, it'll serialize all incoming and outgoing data based on that schema. So if your schema fully covers what your route will do, Fastify is actually able to process incoming routes faster because it knows exactly what data it's going to be receiving. It doesn't have to do any sort of guessing or checking during like the runtime, so to speak. The other thing is the security, where if you are defining that your body should be of some shape, it should have some explicit properties, and those properties are required, and the body doesn't have those properties, then Fastify will actually never even run this handler. We'll just say, nope, we'll 500 server or some 400 or 500 error, this isn't valid. We provide other mechanisms, like hooks so you could run some code if that error hits. But for the sake of simplicity, just think that if the schema doesn't pass, the route handler doesn't execute. But what about TypeScript? Remember before I showed you how we can provide types for these 4 properties for our incoming request object. And now we're validating that request object based on some schema. So how do we connect those two things together? The types of these 4 properties, as well as the schemas that we're writing for our routes. There are 2 existing solutions, both I've used and really enjoy using. The first one on the left is really great for projects which would have large amounts of routes and schemas, and as well as a big existing tool chain. You write your schemas using just in JSON, following the JSON schema spec, and then you pass it to this CLI, JSON schema TypeScript, and it will generate TypeScript definitions for you based on that JSON. And then you can import both of them into your route and pass the interface as the generic to your route, and then pass the corresponding schema as well. And then your 4 properties inside of here will get the types based off this route schema and will also be validated. And you actually have fairly type-safe code at runtime. It's not actually type-safe, but it's as close as we can get. On the right, here's a more interesting one. And this is a Fluent-like API. This is called Typebox. And you define your schema using this type API. It's called, you do type object, and then inside that object, you define a property, let's say body. This corresponds to the schema, the body part of our request. And then that body is also an object, and it has a property foo, which is of type string. This schema here, what's returned from type.object, is a valid JSON schema. So you can pass that right on into your request. And then your generic here can be derived directly from that object using this same library's static type analysis. So this one is also very cool. It can be used, it's very testable. It's very dry, and it helps, keep your schemas more understandable because they're written in code. They're not just JSON. So what if we took TypeScript 4.1 and that sort of like the ability to process JSON that we've seen examples of, combine it with Fastify's existing validation part, as well as just a JSON schema spec. In theory, we could have a solution where there is no need for a generic here, where a user can just pass in their JSON data to the schema field, and the underlying type system would be able to infer all of the types from that JSON and apply it through to query string body headers and parameters. And this is one of the things that we're really excited to start experimenting on when 4.1 is released. And it's in beta, so we've already started experimenting. But of course, we're gonna, we'll wait until the major release until we actually put it into action. So that's about all I have for today. I would say if any of this has sparked an interest in you, please come and check us out on GitHub. We are a growing community and we're very welcoming. If you have never made an open source contribution before, come on in. We are more than happy to help out. We have a bunch of repositories that you can contribute to with all a very low barrier of entry. All of our source code is written in just ES6 JavaScript, and we don't use blurs, we don't use anything fancy. Some of our plugins are written in TypeScript, which is great for TypeScript developers. And of course, if you're, if you like the sort of patterns I've shown today, you can see all of that and more within the Fastify project itself. We ship all our own types, and all the type definitions I shared today are based off of the real ones inside of the Fastify project. So thank you very much. Again, my name is Ethan Arrowood. I'm an engineer at Microsoft. I thought this GIF would be funny because we're getting close to Halloween, my favorite holiday. And feel free to reach out to me on Twitter. I love chatting about TypeScript, JavaScript, Node.js, and plenty of other things. So, all right, that's all I got. Thank you again.
Ethan, thank you so much for that. That was really insightful. And I think that also builds on a talk that we had at the previous meetup where we had, I think, Mano. He discussed some of these validation challenges with TypeScript where you're trying to essentially take runtime validation and perhaps generate types from it and vice versa. And so I think we have a really, really exciting future very soon. If we're able to get that, as you suggested, with the template literals from the JSON schema. So that's really exciting. Do you have anything, before we get to the Q&A, do you have anything else to share about Fastify? I think it's a really exciting framework, and we're seeing more and more adoption of that.
Yeah, I'd say, just to reiterate, the open source community, we have a Discord channel, we have discussions enabled, we have a help repository. So come and chat with us, ask us questions. We have our maintainer base has been growing a ton over the past year because we're really just trying to just be this great big community of framework developers. So even if you don't use Fastify, if you're an Express or Happy or you got your own framework, I know Prisma has done some stuff with, I think the Blitz.js folks, they're working on their own thing underneath the hood. I say, come and chat with us. We love the framework ecosystem, web frameworks. We want to see and help each other grow. So thanks all.
That's great. Okay, so thank you all for all of the comments. We'll now take some questions. Are you ready for some questions, Ethan?
Definitely.
So if you have a question, I think it would be a good time now to drop the question in the chat. We also have an interesting comment. Thanks. Interesting to see how TypeScript syntax is becoming more and more like a language of its own to construct types. Indeed, yes. Mm-hmm. Okay. And if there are no questions, I guess the talk was crystal clear. Great. Okay, so now we will move on. So thank you so much, Ethan.